Hello, everyone, and welcome to another Mini Sky tonight. So one of the topics I've sometimes come across while in the planetarium is people have often mentioned that NASA is a no longer needed organization. It's a bygone era. We've kind of explored a lot of vastness of space and it's not needed anymore. And there's a lot of more problems here on Earth. Like we have all these different pandemic problems, and that it would be better just to focus inward than to go outward. And I can understand where they're coming from because we do have a lot of things that require our attention. But before you press the stop button on NASA, allow me to present to you things that we use every day thanks to NASA. So sometimes when NASA is working on research and development for going off to space, some of the items that they develop then spin off into the public domain that we use today. And they wouldn't have been developed if we didn't have a space program. And without research and development, some of the things we wouldn't think of having do exist today. And we need to have that research and development to have other things to come into play. So let's take a dive at some of the things you use every day that you didn't know came from NASA. Step one, freeze drying. I wanted to start off with an easy one. So some of you may have gone to the Johnson Space Center or the Kennedy Space Center and have tried out these astronaut ice cream of some kind. It was first developed in 1938 by Nestle because they wanted to create a freeze-dried supplement for pilots and astronauts going into space that, one, didn't flake off, two, didn't rot or deteriorate over time, and three, has a long shelf life. So working with them and different types of foods and everything, they were able to create a space ice cream to where it retained 98% of its nutritional value and weighed less than the original ice cream. And they were able to do this with different types of food as well. And that technology is still used today when we send stuff into space on the International Space Station. So we're able to create these freeze-dried pouches that then can be used on the International Space Station so that astronauts can still have food, but yet they're small, compact, and lightweight. Space blankets. It was originally developed in 1964, and these blankets, they wanted to be able to allow the astronauts to basically cover up now and then, but they wanted to get a blanket that wasn't cloth or wool of some kind, because believe it or not, your clothes shed over time. Hence why you have to use a lint dryer when you dry them in a dryer, because flakes and bits of pieces come off of your clothes. And because of that, if it flakes off on the International Space Station, gets into the air filter system and can clog up the air, which is a big problem. So they wanted to develop a blanket of some kind that was lightweight and didn't flake off. Fortunately, these space blankets, because they're kind of made of like a mylar type of material that basically retains and deflects IR radiation very easily. And it's incredibly lightweight. And since they used it for the astronauts, it was able to spin off into the public domain to where it's used in many first aid kits and emergency packs. Memory foam. So for those of you that have an awesome memory foam bed, you can thank NASA for that. It was developed by the Ames Research Center because they were trying to look for improved padding for crash protection, because they sometimes had astronauts and pilots that were going at several Gs, and they wanted something to help protect them while being pressed with the heavy Gs, as well as something that can help them should they hit a crash to basically take the blow. And they developed this type of foam, that retained its shape over a period of time, a memory foam, if you will. So that memory foam was then sped off into Tempur-Pedics, to where the only crashing you will do is on your own bed. Next up, Bowflex. So believe it or not, for you health junkies that love to exercise a lot, you can thank NASA for Bowflex. Bowflex approached Paul Francis to be able to create a weightlifting system that didn't require weights. Because when you're on the International Space Station, you're in a state of constant free fall. You're not, quote unquote, weightless. You're just constantly falling towards the Earth, which makes you feel weightless. And the problem with that is that most things that normally would weigh several pounds on the Earth hardly feel a thing. In fact, one astronaut, she often quoted, when she went to the International Space Station, she felt like Superwoman because she would carry these several 100-pound bags of water to refill the water systems. And they were several 100 pounds on Earth, but she was just lifting them with her finger and pushing them. So why do they need an exercise machine on the International Space Station? Well, over a period of time, NASA realized that the astronauts would go to the International Space Station. They had the problem of muscle deterioration because they're not using them as much as what we do here on Earth. Where here we have to stand up and walk around and have the constant force of gravity pulling down on us. There they don't. And so they had muscle deterioration over a period of time because they were using their muscles much less. And so NASA wanted to be able to have the astronauts continue to work out and to retain that muscle while still in a weightless type of environment. So they approached Paul Francis to help them develop a system that didn't require weights to be able to exercise. And together they were able to develop a system that uses elastic retention and resistance versus actually having to lift a physical weight, creating Bowflex, to where the system takes the elastic part of the, kind of you can see on top, the elastic retention as you pull, and it can equate using a bunch of mathematics to how much pull that weight would be. So in 2000, it was placed on the International Space Station because one of the other things they had to keep in mind too is like, okay, you got to make this compact. So it can't be this big, huge, heavy duty machine, but yet it can't be, it has to be lightweight and compact enough. And so in 2000, they were able to develop Bowflex and they were able to place it on the International Space Station so the astronauts can continue to exercise. And then in 2005, it was released for commercial. Seismic shock absorbers. So for some of you that have been in tall buildings, especially around in San Francisco, you may have seen these. They were developed by Taylor Devices as a means of safely removing the fuel and electric connectors from the space shuttle during launch. So as the fuel and electrical connectors are attached to the space shuttle prior to launch, they wanted a means to remove them without just being flung off and then they drop down on the ground. So they used a means to allow them to, kind of like an arm to allow them to release. Well, they then use that technology inside architecture so that way you don't feel the heavy vibrations as much from a lot of earthquakes. Next up, improved Goodyear tires. Goodyear Tire and Rubber Company partnered with NASA to create this fibrous material that is 5 times stronger than steel because they wanted to use it in their kind of like parachute shrouds to soft land the Viking lander on Mars. They're basically kind of like the bubbles that were surrounding the Viking lander to help them land softly and then deflate over time. And since the Martian soil is covered completely in rust, it's like basically landing on a bunch of rusty nails. So you wanted something that was strong, that didn't just pop the second that it would land, but yet was able to be blown up into a parachute of some kind. Well, they then spun off that technology to work inside their tires to where they were able to increase tread life of their tires. So they were able to mix it in with their rubber to give you longer lasting tires. So rather than having to change it every 1,000 or 2,000 miles, you can now have tread life that can last up to 10,000 miles. Next up, LASIK technology. So for some of you that have gone through LASIK surgery, you can thank NASA for this technology. It was developed in 1980 as a means to dock with service satellites. So they would basically have this laser detection that would basically keep track of motion of the satellite for every several thousand seconds to be able to dock with it, so that way they can dock perfectly. So two satellite detection motions programs were brought forward first. One was called LADAR, which is constantly used today because it proved more capable, and it was also developed with other types of devices in mind, including missiles. So that's what they kind of used currently to dock with the International Space Station. But LASIK, however, was still really good. And it's used by ophthalmologists to track eye movements at 4,000 times per second. So this technology that basically helps you to improve your eye was able to track the movements of your eyes. Scratch-resistant lenses. So for some of you that have to have glasses, you can thank NASA and Foster Grant. They were basically working together to develop means to protect their helmets and visors and other glass surfaces from getting scratches. Because when you're doing spacewalks and extravehicular activities, you have to worry about getting your visor scratched. And so they developed this type of glass material that was scratch resistant for some small little specks. And that technology now is used in almost every pair of glasses. So you can thank NASA for having glasses that you don't have to repair just from one tiny minor scratch. Dustbusters. So for growing up in the 80s, I remember using one of these handheld little devices constantly to clean up a bunch of messes. It was developed by Black & Decker and NASA because they wanted to create a self-contained drill capable of extracting cores on the moon. And they created a computer program that was able to create this small little device. Well, from that program, they were able to say, hey, maybe we can modify this program to look for ways to create a miniature version of other types of devices, such as, say, a vacuum. So from being able to create a self-contained drill, they were able to create a self-contained vacuum. THERMAWNG and THERMACOOL. It was developed by the NASA space program because one of the things that they noticed that was a big, huge problem as the shuttle was going up into space is that some of the wings was starting to get cold and they would develop frost and ice. So they needed to create a means of de-icing the wings and or keeping them cool in the Florida temperatures. So they developed this kind of heating and cooling system inside the wings that allowed it to easily de-ice the wings and to keep them cool during the heat. And ThermaWing is used in many space aircraft today. So you can thank your safe flying on different commercial aircraft to NASA. Speedo LZR racers. Okay, so this is not something that may be used constantly, but you can thank our gold medal Olympics winners can thank their gold medal to NASA. This unique type of swimsuit was developed by Speedo and the Langley Research Center wind tunnel. They were basically looking at how aerodynamic the human body was, and Speedo worked with them to create this unique swimsuit that can help reduce skin friction by 24% rather than normal swimsuits. And for Olympic swimmers that have worn these and competed, at least 13 swimming world records were broken thanks to this new technology. OpenStack. So for some of you computer whizzes that use this service, you can thank NASA. It was originally developed by NASA and it was called Nebula. It was a means of basically storing and creating different types of products without having to store it on a physical drive, because As we all know, memory space in your computer is always a limited resource. So in 2010, NASA released this code as open source to the public, and then they partnered with Rackspace to form OpenStack. And last but not least, improved gold plating. Now, gold plating and copper plating has been around for a long time, but with new technology, they were able to improve upon it to be able to gold plate a lot of different things. NASA partnered with Epner Technology to be able to gold plate things much easier than by the standard means, and as well as to do it for much larger surfaces and more efficiently. Why gold, you may ask? Well, gold doesn't oxidize in normal air conditioned spaces, and it doesn't rust. It doesn't basically turn this green color like copper over time, so it just keeps this natural glow glisten. And it also collects IR very well, and it can also protect from certain types of radiation. So it makes it a very valuable asset for space exploration. In fact, the new James Webb Space Telescope is going to be using gold mirrors because it can collect IR radiation much easier. And from this new improved method, new gold plating is easy to do, including Oscar statues. Epner Technology has promoted for those that have a golden Oscar that if it basically tarnishes over time, they will re-gold plate it. So this is some of the technology that has spun off from NASA research and development. So before you think, oh, we should use the budget for something else, keep in mind, some of the things that they develop can be used in our next generation. So who knows, maybe the newest development will become the brand new thing that we use. So if there's a question you would love for me to cover over, leave it down in the comments. Or if there's a suggestion or a topic you would love for me to cover over, leave it down in the comments as well. And until next time, stay safe, stay healthy, and as always, never stop learning.